and I'm really excited to kick things off today. Now, before we dive into the technical talk, I just want to take a couple of minutes to tell you about our TAC webinar series. So, what is this series all about? Simply put, it's a space for our TAC team and customers like you to connect live and share knowledge. We cover technical topics that are highly relevant to the issues typically seen across customer environments. Since we started this initiative in 2022, we have walked through a variety of subjects, everything from switch health checks and packet drops to EVPN, VXLAN, AI workloads, and much more. Today's session will be all about troubleshooting campus network issues, specifically around RadSec and 802.1x. Now, since these issues can be tricky to diagnose, we are excited to have Brian Miller, one of our best, walk us through how to identify and resolve common problems in these setups. Brian's got a ton of hands-on experience with the product. So trust me, you are in great hands today. Along with Brian, we also have a few other engineers from our TAC team to help answer your questions live. So please don't hesitate to use the Q&A box throughout the session. If you're registered, you should have received a link to download the topology diagrams last week. But in case if you missed that, no worries. We will drop the download link in the chat shortly so you can grab it now. It will be helpful to have it open for reference as we go along. All of our past webinars with the session recordings and lab configs are available on the Arista community page, reference on this slide deck. Now, before we wrap up the intro, I would like to highlight one more custom offering by TAC. This is a paid training service we launched based on customer feedback and growing demand for personalized sessions. While our webinars cover general scenarios, these sessions are fully tailored to your specific environment, your platform, your features, and your architecture. We dig into recent TAC cases linked to your account, review the top issues you have faced, and share detailed troubleshooting guidance and preventive recommendations, all delivered by our TAC subject matter experts in a hands-on format. The feedback we have received so far from both our enterprise and cloud customers has been incredibly positive. If you're interested or want to learn more, just drop a note to tag-custom-training@arista.com and we'll be happy to help you out further. Now, without further ado, let me give the baton to Brian to take it further. Brian, you can take it further.
Okay, great. Thanks, Neha, for the introduction. Give me just a second here to share my screen. All right, if someone can just confirm that that's visible.
Yeah, we can see it now. Thank you.
Okay, great. All right, then let's get started. Welcome, everybody, and thank you all for joining me on this campus-focused TAC webinar. My name is Brian Miller, and I will be presenting Troubleshooting RadSec and 802.1x. Excuse me. The agenda for this session will cover RadSec connectivity verification and troubleshooting, 802.1x MAC-based authentication delay diagnostics and log tracing, and finally, 802.1x EAP TLS certificates and user enrollment issues. Let's start by reviewing the following topology. Here we've got a basic campus setup comprised of both wired and wireless clients connected to the network either via an Arista switch or access point with additional services provided by various cloud resources. Stepping through each of the components, the AGNI radius server is responsible for providing AAA functions by authenticating users either against its local user database or that of a connected IDP, authorizing successfully authenticated users for specific network access privileges, and maintaining an accounting log of each user's session. Authenticators act as the gatekeepers to the network, In this example, the campus switch and access point receive the initial connection request from a user or supplicant and initiate the authentication process by relaying credentials from the supplicant to the Radius server, permitting or denying access to the network based on the Radius response. EAP-TLS is the certificate-based flavor of EAP, wherein the supplicant provides a certificate for authentication as opposed to using a username and password. Endpoint management, Microsoft Intune, shown here, provides a centralized mechanism for device policy definition and enforcement on enrolled clients. Profiles can be pushed to clients containing configurations for wireless networks, SCEP enrollment, certificate chains, and other application or security-focused details. IDP, or Identity Provider, Microsoft Entra shown here, is a centralized system or service that creates, manages, and stores digital identities and provides authentication services to other applications and systems. MBA, or MAC-based authentication, allows for the use of a supplicant's MAC address in place of a username and password or certificate for 802.1x authentication. This is useful for clients that don't support 802.1x natively, such as printers, IP phones, or other IoT devices. RadSec, or Radius over TLS, is a protocol designed to secure the communication of Radius messages by encapsulating them within an encrypted TLS tunnel, adding a layer of robust security to the traditional Radius protocol. This allows the on-prem authenticators to pass Radius traffic to the AGNI cloud instance in a secure, encrypted manner. SCEP, or Simple Certificate Enrollment Protocol, automates the issuance and management of client certificates. This enrollment process will be covered in greater detail later on in the presentation. And finally, supplicants. They are the end devices looking to connect to the network and are responsible for initiating the authentication request with the authenticator and providing credentials. The first scenario we'll be looking at deals with the wired portion of the previously reviewed topology. During a new campus deployment, this customer found that after they had configured their switch for 802.1x and added it to AGNI, none of the devices connected to the switch were able to authenticate. They noticed from the AGNI side that the RadSec tunnel responsible for securing the Radius traffic from the campus switch to AGNI was showing not connected. Before we jump into the troubleshooting, let's briefly review the configuration steps needed to set up a RadSec connection between AGNI and an Arista switch. First, a CSR is generated on the switch, with the CN matching the switch MAC address and the DNS name matching the switch hostname. Next, the switch gets added to AGNI under the Access Device section. After the switch is added, the CSR is used to generate a certificate signed by the AGNI RadSec CA cert. Both the signed switch certificate and the AGNI RadSec CA cert are then uploaded to the switch, moved to the certificates directory, and added to an SSL profile. Finally, a Radius host entry is added to the switch, pointing to AGNI with the SSL profile specified. Oh. To troubleshoot this problem, we'll use the following approach. First, we'll verify that the issue is still happening. Then we'll check the connectivity between the campus switch and AGNI. After that, we'll review the configuration and based on our findings, formulate a hypothesis that we can test. From there, we'll take corrective action and finally check to see that the issue has been resolved. Starting with verifying the issue, let's jump over to the AGNI interface and check the RadSec status. From the AGNI homepage, looking at the access devices, here we can see that the RadSec status for the access point shows connected. However, the status for the campus switch is showing not connected. While we're here, let's also go to System, RadSec Settings, where we can verify the hostname of the AGNI instance that we should be using on the switch. We can also copy this hostname using the button on the right. Now that we've confirmed the RadSec connection between AGNI and the switch is indeed down, let's move to the switch CLI to check its connectivity to the AGNI cloud instance. At the switch, let's start by checking basic connectivity to AGNI using the ping command and the hostname copied earlier from the AGNI interface. Here we can see that the ping was successful, indicating the switch has no issue reaching AGNI in the cloud. Now let's take a look at the output of show radius. In the output here, we can see that port 2083 is being used for the RadSec connection, and that the traffic is being sourced out of interface VLAN 1. Now, to confirm connectivity over port 2083, we can use Telnet, but let's also get a TCP dump running to verify bidirectional communication. Setting up the Telnet connection to the same AGNI instance hostname as before, specifying port 2083, and setting up the TCP dump to capture traffic on VLAN 1 filtered for port 2083. First, we'll start the TCP dump, and with that running, we can now try the Telnet connection. All right, from the packets captured here, we can see that there is bidirectional traffic between the campus switch and AGNI over port 2083. So this verifies that connectivity between the switch and AGNI in the cloud isn't our issue. With connectivity verified, let's move on to reviewing the switch configuration. Back at the switch, let's start by confirming both the signed switch certificate and the AGNI RadSec CA cert are present in the certificate directory. To do this, we'll use dir certificate and look for any file ending with a .pem extension. In the output, we can see that both certificates are present, so let's move on and check the SSL profile to confirm the certificates have been added there using showrun section SSL profile. Here we can see both the signed switch certificate and the AGNI RadSec CA cert have been added in properly. So at this point, it looks like the configuration is accurate. Let's go ahead and take a closer look at the status of the SSL profile. To do this, we'll use the command show management security SSL profile, specifying our profile name AGNI server and detail. Okay, now here we can see a problem. The profile status is showing invalid, and we don't see any certificate tied to the profile. What could be causing the SSL profile to show as invalid? We've confirmed the configuration is accurate, but there could still be an issue with the certificate itself. For now, let's move ahead with that assumption and take a closer look at the switch certificate. Before we check the certificate, let's first confirm the switch MAC address and hostname. And with that done, we can now inspect the certificate. Our first option for this is to simply output the raw base64 encoded PEM file and copy that output into an SSL decoder. When doing this, be sure to copy everything, including the begin certificate and end certificate lines. However, because we're on an Arista switch running EOS, we also have the option of decoding the certificate directly on the switch using OpenSSL. In the output here, we can see that the DNS entry matches the switch hostname and that the CN matches the switch MAC address. Now, looking at the certificate validity, we can see that it starts at 1800 GMT on May 15th, or around 2 p.m. Eastern Time. So everything with the certificate is checked out. Now let's take a look at the switch time to be sure that it's accurate. And we'll do this using show clock. All right, here we can see another problem. The switch is using local time as its source and currently thinks that it's Wednesday, May 14th, not Thursday, May 15th. This also explains why the SSL profile was showing invalid. From the switch's perspective, the certificate isn't yet valid. Now that we've identified this problem, let's correct the switch time and reset the RadSec connection to see if that resolves the issue. We'll correct by adding a couple of NTP servers and then setting the clock source to NTP. Once NTP has synchronized, we can check the time again using show clock to see if it's accurate. And with time now accurate, we can reset the RadSec connection by going into management security, specifying our SSL profile AGNI server, and then removing and re-adding the trust certificate. All right, and with that done, let's check the SSL profile status again with show management security, SSL profile, AGNI server detail. All right, this looks promising. We can see that the profile state is now valid and that our switch certificate is specified in the profile. Let's jump back over to the AGNI side and see what the RadSec connection status shows now. Back at the AGNI interface, checking the access devices, we can now see that the RadSec status for the switch is showing connected. And with the RadSec connection up, let's see if wired hosts are able to properly authenticate. To test if Radius is working, a device has been plugged into Ethernet 7 on the switch. We can see that the interface has changed its state to up, but don't see any authentication as of yet. Let's just give it a little bit of time. Okay, we can see that the supplicant did finally authenticate. However, looking at the timestamps, it took over 1 minute for that process to complete. So we've solved one issue, but uncovered another. What could be delaying the MAC-based authentication? This brings us to our second problem. As we saw, MAC-based authentication is successful, but is taking an excessive amount of time to complete. In the real case where this issue was seen, we also confirmed that this wasn't isolated to a single device. All devices connected to the switch were impacted and experiencing the same exact delay. We'll use a similar troubleshooting approach here, building on the information we already have to move forward and focus on this new issue. We know the RadSec connection and connectivity are solid, so let's start by taking a look at the .1x configuration on the switch. Back on the switch, we'll use show run section .1x to display the .1x configuration. And here we can see that Ethernet 7 has .1x enabled at the port level with the .1x PAE authenticator command. .1x port control auto allows the switch to change the port from unauthorized to authorized state based on the radius response. The port is also configured in single host mode, meaning once a supplicant authenticates on the port, only traffic from that supplicant MAC will be allowed. And finally, we see that MBA is enabled with the .1x MAC-based authentication command. Now, from a global perspective, .1x is enabled with the .1x system auth control command. Also, we can see .1x protocol LLDP bypass, which allows LLDP traffic to flow through the port prior to authentication. And .1x dynamic authorization enables support for COA or change of authorization messages. This allows the Radius server to adjust the supplicant's session dynamically, such as changing their assigned VLAN. So everything with the .1x configuration looks good. Now let's move on to check the Radius configuration with show run section Radius. Here in this output, we can see that the AGNI radius host has been added in correctly, but we can also see that there are 3 additional radius server host entries. Also, looking closely at the AAA authentication and accounting entries, we can see that they are set to default group radius. This indicates that the switch will use all radius hosts configured, as opposed to just using the AGNI server group, which specifies just the AGNI host. Now, let's try authenticating this supplicant again, but this time we'll check the output of show.winx hosts while waiting for the supplicant to authenticate. We can see the MAC address of our supplicant trying to authenticate. It is in fact trying to use MAC-based authentication, but the state we see here is showing wait for auth server. Based on the radius configuration and the wait for auth server state seen with show.winx hosts, it appears the additional server entries are causing the delay. Let's replicate the issue once again, this time looking at the .winx Qt logs to validate this theory. The Qt logs, also known as quick trace logs, provide detailed process and function level agent debugging, allowing us to see exactly what the .winx agent is doing during the authentication attempt. To view the .winx Qt logs in real time, as the supplicant attempts to authenticate, we can use bash qttail followed by the path to the .winx Qt logs. Also, due to the verbose nature of this log, we'll be filtering the output using grep-e for just the session and server timeout log entries. All right, we can see that the port has changed its state to up. And as we suspected, the switch is trying one of the other radius host entries. We can see here that these sessions are also timing out, with the switch having to retry the connection to that radius host multiple times before moving on to the next radius host in the list. Now, this behavior repeats with each radius server host on the switch tried a total of 4 times, with a 5-second delay between each attempt, leading to a total delay of 20 seconds per host, or 1 minute. Before the switch finally gets to the AGNI host entry and the supplicant successfully authenticates. So based on this output, we can tell that these additional radius host entries are what is causing the delay with MAC-based authentication. Now that the log data has confirmed the hosts are responsible for the authentication delay, what options do we have to address it? So the easiest option would be to simply remove the additional radius host entries from the switch. However, another option would be to change the AAA authentication and accounting entries to point to just the AGNI server group. And with that done, we can see that both AAA authentication and accounting are now pointing to the AGNI server group, and that the AGNI host is the only remaining radius server entry on the switch. Now it's time to check and see if these changes have made any difference with the supplicant authentication. Connecting our host once again, we can see that the supplicant authenticates much more quickly. However, there's still about a 5-second delay between when the port comes up and the supplicant authenticates. Now, this delay is actually due to a system default setting. We can change this by going into the global .winx configuration and setting the MAC-based authentication delay to 0 seconds. With that change made, we can now see that the supplicant authenticates almost immediately once the port comes up. This concludes our first troubleshooting scenario. Let's take a few minutes to review. The primary issue faced by this customer was wired clients failing to connect to the network. The customer had a newly implemented 802.1x configuration involving their campus switch and cloud-based AGNI. Upon initial review, it was confirmed that the RadSec connection between the switch and AGNI was down. RadSec is critical to this deployment as it's responsible for securing the radius communication between the on-prem gear and AGNI. Without it, clients will not be able to authenticate. We started by validating connectivity between the campus switch and AGNI using ping and a telnet connection to port 2083. This confirmed both general connectivity to AGNI and specific connectivity on the RadSec port. Next, we looked at the configuration, confirming that these certificates were present and added to the SSL profile. Checking the status of the SSL profile is where we found the first issue. Its state showed invalid and no certificate was loaded. This led to the decoding of the signed switch certificate where the validity dates, CN, and DNS entries were confirmed. After the cert checked out, we finally looked at the time setting on the switch, finding that it was using local time and about 24 hours behind global time. This explains the SSL profile state. From the perspective of the switch, the certificate wouldn't be valid until the following day. To correct this, we added a couple of NTP servers to the switch, waited for time to sync, and then reset the RadSec connection. After the reset, the SSL profile showed a state of valid with the signed switch certificate loaded, and we confirmed from the AGNI interface that the RadSec status showed connected. This, however, led to the discovery of a second problem. Once the RadSec connection was up, wired hosts were able to authenticate. However, there was an odd 1-minute delay seen with MAC-based authentication. We started here by reviewing the .1x configuration on the switch, seeing that it was properly enabled both globally and at the interface level. After this, we replicated the issue whilst looking at the output of show.1x hosts. Here we saw that during the authentication delay, the state was wait for auth server. This led to looking at the radius configuration, where we found that 3 additional radius host entries were present, as well as the expected AGNI entry. Additionally, the AAA authentication and accounting configs were pointing to group radius instead of the specific AGNI server group they should have been using. To confirm that the additional radius entries were the reason for the delay, we replicated the issue a second time with live output from the .1x Qt log. Here, we were able to see the switch trying each radius host individually and timing out one by one until finally reaching the AGNI entry, at which point the supplicant authenticated. To fix the delay, the additional radius host entries were removed, AAA authentication and accounting was pointed to the proper AGNI server group, and finally, the MAC-based authentication delay was set to 0 seconds, reducing it from the system default of 5 seconds. With this done, the wired hosts were able to successfully authenticate immediately once the port came up. Excuse me. Before moving on to the next troubleshooting scenario, let's quickly review the SCEP enrollment process. The process starts with the endpoint management server pushing profiles to the client. These profiles contain wireless network details as well as the certificates for and URL of the SCEP server. The client then sends a CSR or certificate signing request along with a dynamic challenge to the SCEP server. The SCEP server will then request an authentication token for the endpoint management server from the IDP. The IDP responds with the auth token, allowing the SCEP server to forward the CSR and dynamic challenge from the client to the endpoint management server for validation. If the dynamic challenge matches, the endpoint management server replies to the SCEP server approving the request. Upon receiving the approval, the SCEP server issues the signed certificate to the end client. With that process reviewed, let's take a look at the final problem. The same customer from earlier has moved forward with their deployment to now include SCEP device enrollment for their wireless clients. After configuration, however, enrolled clients are unable to join EAP TLS secured wireless networks. The customer states that the enrollment process appears successful and clients sync with the endpoint management server, but attempts to join the wireless network fail with a certificate error. Our troubleshooting approach here will be similar to before. We'll start by replicating the issue, then review any relevant log data across the platforms involved, form a conclusion based on our findings, implement corrective action, and finally, confirm that the issue has been resolved. Let's try onboarding a new host to see if they're able to join the network. To onboard this Windows client, we'll go to the Start menu and then Access, Work, or School. From here, we'll select Enroll Only in Device Management and enter the Azure account for this user. Now, we'll wait for the endpoint management server to send the profiles to the device. Once the profiles have synced with the device, we can check them by clicking the Info button. Here we can see that a Wi-Fi profile has been pushed and that the device sync was successful. Now let's see if this client is able to join the wireless network. Just like the customer described, we can see here that the client fails to join the network, and it says that a certificate is needed to sign in. We've confirmed the device onboarding was successful, but the client was unable to join the wireless network. Let's take a look at the log data. Starting on the endpoint side, first, we'll take a look at the certificates. Here in the Trust Store, we can see that the AGNI root and issuer certs have been installed. However, checking the personal certificates, we see a certificate for Intune, but there is no SCEP certificate installed for the user. Now, let's move to the event viewer logs and see what that shows us. Going to Applications and Services logs, Microsoft, Windows, Device Management Enterprise Diagnostics Provider, and selecting the Admin section. Looking at the information and the error messages here, we can see that they are all reporting issues with the SCEP certificate installation. Now let's check the other components to see what their logs show. Moving to the Intune side and checking under Devices, Windows Clients, we can see here that our host has registered with the endpoint management server, and checking it, we can see what its device configuration shows. All right, device configuration shows that 3 of the 4 profiles were successful, but the SCEP profile failed and is showing an error state. Looking at the profile, though, there isn't any information here as to what caused the enrollment to fail. Now moving to the troubleshooting section and checking our user account, we can see that the account is enabled and licensed. Also, we see the policy error shown again, seeing that the SCEP policy is the one that failed, but still there aren't any details as to what caused the error. Now let's move over to the AGNI interface and go to the system and support logs, checking for any PKI SCEP messages. We can see that AGNI is processing an incoming message from the client. The body of that message sent from the client. AGNI is processing this message for enrollment. Now, first, AGNI will check to see if there's any existing PKI information for this client. And this error here indicates that there isn't a certificate found for the client, which in this case is expected as it's a new enrollment. Now, AGNI attempts to validate the challenge password, and this looks to be where our error is occurring. We can see here that the challenge could not be validated, and that there was an error extracting user and device details. It failed to get UPN or emails from the CSR provided by the client. AGNI will then send that failure response. So this here seems to be what is causing SCEP enrollment to fail. We are missing user and device details in the CSR to validate the challenge password against the endpoint management server. Based on our findings from these logs, there appears to be an issue with the SCEP profile configuration, not providing UPN and device details as part of the challenge to the SCEP server. Let's go back to Intune and take a closer look at the SCEP profile. On the Intune interface, let's review the SCEP profile under Devices, Windows, Configuration. Here we can see the profile and showing the error that occurred earlier. And scrolling down to the configuration settings, we can select Edit to check the settings on the profile. We can see the subject name format is set to user principal name, but there doesn't appear to be anything here to provide device ID information. Let's compare this against the Arista Community Central Configuration Guide to see if anything was left out. Moving down to the Microsoft Intune configuration section, and scrolling down a ways here to reach the SCEP profile, we can see that the subject name format does need to be set to user principal name, but looking just below that, we can see that there is actually two additional attributes missing from our profile. One for the user principal name and another defining the device ID. So now that we found that problem, let's add those missing attributes to the SCEP profile. The first attribute we'll add is for user principal name with a value of user principal name. And the second attribute is URI with a value of device ID. With those attributes added in, we can now save the updated profile and navigate back to the client device. From this screen, we can push the updated SCEP profile to the client again using the sync button. And now let's check the AGNI logs to see if SCEP enrollment was successful this time. We can see AGNI's received another incoming message from the client. The body of the message received from the client. Processing that message for client enrollment. Again, checking if there's any existing public key information for the client. And we see that object not found error as there's no certificate on AGNI for the client. Now AGNI attempts to validate the challenge password, and this is where the enrollment had failed previously. However, this time we can see that the challenge password is confirmed. AGNI is then able to issue the certificate to the client and reports that user enrollment is successful. So back on the Intune side, checking the device configuration, here we can also see that the SCEP profile was successfully pushed to the client. Finally, let's go back to the client and confirm that they can join the wireless network. Refreshing the certificate store, we can now see that the SCEP user cert has been issued to the client and installed. And now when attempting to join the wireless network, this time we can see that it's successful. With that, we've confirmed the SCEP profile has been fixed and clients are able to join the network. Let's take a moment to review our findings. The first step we took was to replicate this issue, confirming the problem was still present and generating a fresh set of logs. From the logs reviewed on the client side, we found that the AGNI certs were installed, but the SCEP user cert was missing. Event viewer logs further confirmed that the SCEP certificate installation had failed. The Intune side also confirmed this, showing an error with the SCEP profile on the device configuration, though it didn't provide any further details as to what caused the error. On the AGNI side, the logs indicated the SCEP process failed when trying to validate the challenged password, specifically showing error while extracting user and device details, failed to get UPN or email from CSR. Based on this information, we reviewed the SCEP profile settings on Intune and checked them against the documentation. There we found that 2 additional attributes were missing from the profile, namely the user principal name attribute and the URI attribute containing the device ID. After adding those attributes to the profile and syncing it with the client, we saw that SCEP enrollment was successful and the client was able to join the wireless network. This slide provides links to relevant configuration guides for topics covered in this presentation. And with that, this TAC webinar has concluded. I'd like to thank everyone again for joining me. And now I'll hand things back over to Neha to close out this session. Thank you.
Thank you, Brian. That was an awesome session. We hope everyone found it helpful as well. Now, the recording will be up soon on our Arista community page. We have shared it on the Q&A section. We'll also share it on the chat. And beyond today's material, the community page also has a ton of helpful articles and resources written by our own Arista experts. So definitely worth exploring if you're looking to deep dive into any of the topics. We will be back with another session soon. So stay tuned. In the meantime, we have just dropped a quick feedback form in the chat. Your feedback helps us shape our future webinars. So we would really appreciate if you can take some time and fill it out. Now I'll keep the webinar open for a few minutes in case anyone have any questions. Our panelists are here and you can raise the questions on the Q&A side. All right, it doesn't seem like anyone else have any questions. So I'll consider it a wrap. Thank you again very much for attending the session today, and we hope to see you again in our next webinar. Until then, take care and have a great rest of the day. Thank you.